open math, talk about our first exam, which is coming up for next weekend. Okay, first let's talk about today's material. So we're going to talk about, okay, this is a long name, solve system of linear equations with two variables. Okay, what does that mean? System of linear equations, usually two of them. Okay, so I'll just give you an example. Let's see, we know y equals mx plus b, right? So this represents a line. This represents a linear function or a linear equation. The graph is a straight line. Using an example, we could have y equals 2x minus 1, right? So you see this equation has two variables, x and y. But this is just one. But if I have another one, maybe y equals to 3x plus 3. So now I have two. I have two, and I call this system. Because I have a two, so I call this a system. So I say this is a system of two linear equations with two variables, because x is a variable, y is a variable. Okay, so basically we have two lines. So this is one line, this is another line. What does it mean solve system of linear equations? If you think about two lines that could intersect, if they do intersect, they could intersect at one point, or maybe they overlap. Right? When they overlap, every point intersected with another. So the line, every point will intersect. So basically, they're the same line, right? So that means there's infinite solutions. If they intersect only at one point, there's only one solution. Or sometimes maybe the two lines have the same slope. Same slope lines are parallel. Remember, parallel lines have the same slope, right? Which means they will never intersect, which means the system has no solution. Okay, so we'll talk about this in detail. But anytime, if anyone has any question, feel free to stop me, okay? So each linear equation has a graph of a straight line. Solve system of linear equations with two variables means to find out the relationship of the two lines that can intersect at one point, and we call the point the solution of the system. They can be parallel, which means no solution. They will never intersect. Or they can be the same line, which means we have infinitely many solutions because the two lines overlap each other, which means infinitely many solutions, which means they meet at every point. So three situations. Well, let's see the first one. We want to determine whether that ordered pair, remember ordered pair is a fancy name for a point on the Cartesian plane, is the solution of the system of equation. Well, let's see. So let's see, we have these two lines. Right? One is called x minus y equals -1. Another one is 2x minus y equals -5. Right? And also maybe, so we recognize this represents a straight line. This represents a straight line. How can we tell? Because we have two variables, x and y, and each one has exponent of 1. So we know this represents a straight line. Same thing for this. This also represents a straight line because x raised by 1 and y raised by 1. So when we put those two lines together, we call a system. We call a system. Well, so this one we can write, if we want to write in a function sense, right? So we can move this -y to the other side. We can move this -1 to the other side. So we can write as y equals x plus 1, or f of x equals x plus 1. Same thing for this. We can move -y to the right-hand side, move -5 to the left-hand side. So we can write this equation as y equals 2x plus 5. Someone just sent me a text. Ajeda is saying, that's okay. I understand. Ajeda, don't worry about it. Okay. Just pay attention to the class. Don't worry about that. You're welcome. So we can rewrite as this. And in the function sense, we can write y as f of x. Okay. We recognize this a linear function, this a linear function. All right. So here is another system, right? We put the two lines together. We call system of two linear equations. So we are interested in this equation because we want to know whether they intersect, right? If they do, and where. Okay, definition of solution of a system equation with examples. The solution of the system equation are the values of variables that make all the equations are true, right? A solution of a system of two linear equations make both equations true and is represented by an ordered pair or a point x comma y. Let's see this one. So we have this system of two equations, two linear equations. We wonder if the ordered pair 2 comma negative 1 is a solution of this system, right? Which means x equals 2, y equals negative 1. Can these two values make both equations to be true, to make the equal sign to be equal sign? Well, let's substitute, right? Let's substitute. So x minus y, we can substitute. Okay, x equals 2, right? So that means x equals 2. 2 minus negative 1, that would be 3. Let's do this, right? So we substitute 2 for x and negative 1 for y. So what do we get? We get 2 minus negative 1. What is it? Is it 2 plus 1 equals to 3? And of course it's not. Does not equal to negative 1. So it's not a solution. So 2 comma negative 1, it's not a solution for this system. Because if it doesn't make the first one to be true, we don't even have to check for the second one anymore. All right. If it is true for the first one, we will check for the second one. If it's true for both of them, then we say yes, it is a solution. Well, let's check negative 4 and negative 3. Right. Substitute negative 4 for x and then negative 3 for y. What do we get? Negative 4 minus negative 3, that's negative 4 plus 3, indeed negative 1. Yes, it's true for the first one. Now let's see the second one. The second one we have 2 times negative 4 minus negative 3, which equals to negative a plus 3, which equals to negative 5. Yes, so it's true for both. So the equation, so yes, so it is. So negative 4, negative 3 is a solution for the system, right? So this is how we check. We just plug in x value, y value into the equation to see if it's, to see the equal sign, it is the equal sign. So this one equals negative 1, negative 1. The second one equals negative 5, equals negative 5. So yes, it satisfies two equations. So it is a solution. Anyone has any questions? Well, most of the time, what do? We're not going to check if this point is a solution, if that point is a solution. We want to solve for the system. We have a couple of ways to solve it. So let's see, this is one way. This is saying subtract the two equations vertically, right? We have these two equations, which means we do x minus 2x, negative y minus negative y. Equal sign we don't do minus, we just inherit equal sign. Then we do negative 1 minus negative 5. Let's see what happens. We do x minus 2x minus y minus negative y equals to negative 1 minus negative 5. Then we get minus x, or negative y plus y becomes 0. Then negative 1 plus 5, that's 4. So we multiply negative 1 on both sides, so we get x equals to negative 4. Okay, so for this one, if we subtract, it works. Okay, now we substitute negative 4 for x into any of the equation. Okay, we want to substitute into the first one. Into the first one, we get a negative 4 minus y equals to negative 1. Right? Then negative y, we can move this negative 4 to the other side, become positive. So negative 1 plus 4 equals to 3. Negative y equals 3. We multiply by negative 1 again. So y equals to negative 3. So we find the solution. We found one solution. So x value is negative 4. Y value is negative 3. So this ordered pair, or this point, is the solution. Because we solved it. That's only one solution. That's why we call it the solution for this system. Which means graphically means the two lines intersect at the point negative 4, negative 3. Anyone has any question? Well, as I said, there are a couple ways of doing this system. Solve this system. So another way is we can rewrite x minus 1 equals negative 1, which is the first equation, as x equals to y minus 1. Then we substitute y minus 1 for x into the second equation. Right? So 2x becomes 2 times y minus 1 because those two equal each other. So we do 2 times x minus 1, the minus y equals to negative 5. So I have 2y minus 2 minus y equals to negative 5. 2y minus y equals to y. Minus 2 equals to negative 5. Move negative 2 to the other side, become positive. So y equals to negative 5 plus 2, which is negative 3. Then we plug in to either equation. So we plug in x equals y minus 1. We plug into this one. So x equals to negative 3 minus 1, which is negative 4. So you see, negative 4, negative 3 is the solution, because there's only one solution for this one. The solution of the system. Okay. Then also by this, because there's only one solution, so we can know that any other points is not a solution. Any questions? Some high schools may teach you something called the elimination method, substitution method. So this would be substitution method. Elimination method would be, okay, we see negative y here, negative y here. Maybe you multiply negative 1 for the first one, right? If we multiply negative 1 for the first one, multiply negative 1 on both sides of the equations, we would get a negative x plus y equals to 1. Then with this one, we want to add those two equations. I think that's called elimination method, right? When we add, we add negative x with a 2x, that becomes x, right? Add vertically, add two equations. Get negative x plus 2x, that would be x, right? Y plus negative y would be 0. 1 plus negative 5 would be negative 4. I think this is called the elimination method. Anyone has any questions? But I'm going to delete this, otherwise it's going to ruin my notes. But behind all those different kinds of methods, the principles are the same, all right? You only need to know how to do it in one way, or you can know, in different ways. Okay, the second part is by graphing. All right, let's see these three situations. So we have two lines intersect at one point, right? At one point, only one solution, so one unique solution. Or we have two lines parallel. If two lines parallel, they will never intersect, so no solution. Or the two lines just fall on each other to be the same line. So that means the infinite many solutions, because every point, the two lines will meet at every point. Substitution method, solve system equations, or elimination method. Let's see the first one, by substitution. So we have this system, y equals 5x plus 10, y equals negative 3x equals 3, y minus 3x equals 3. So first we want to rewrite it to line up, all right? So we could rewrite the first one, or we could rewrite the second one. The key is to line up the equal sign with the equal sign. X term with X term, Y term with Y term, equal sign with equal sign, and then constant with constant, right? Oh, hold on. This is substitution method. Substitution method. Substitution method, actually we can substitute right away. Right? So we want to we can rewrite y equals 3x, y minus 3x equals 3. Oh, hold on a second. I have a question. Can I go over how an infinite many solution equation would look? Oh, okay, great. Let me go to whiteboard. Let's see, we have this equation, y equals 2x minus 1. Then I have another equation, let's see, 2x, no, 4x minus 2y equals to 2. Yeah, so I have this system of equations. They look differently, right? They look different. But indeed, they're the same thing. But let's simplify the second one. So the second one, first we can divide by 2. If we divide by 2, we get a 2x minus y equals to 1. Second equation. For the second one, we divide by 2. We divide 3 terms by 2, so we get 2x minus y equals to 1. Now let's just move around, right? Let's just move negative y to the other side. So 2x stay on the left-hand side. We move 1 to the left-hand side. So we get 2x minus 1. We move negative y to the right-hand side, so it becomes positive y. You'll see those two equations are exactly the same. This one, y equals 2x minus 1. This one, y equals 2x minus 1. Right? In the beginning, they look like a different equations, but once we do some simplification, we move around, they're exactly the same. Does that make sense, Ajeda? Okay. All right. Good questions. Good questions. Now let's see this one. So we want to substitute 5x plus 10 for y. All right. So we want to rewrite this as y to be 5x plus 10. So y rewrite to be 5x plus 10. Now the rest are the same. Minus 3x equals 3. Right? Maybe I should do this so you can see clearly the substitution. Okay, we just rewrite the y because y equals to 5x plus 10. So we change y to be 5x plus 10. So we still have minus 3x equals 3. Now we just solve this. How do we solve it? Well, 5x minus 3x, right, on the same side, so we can combine like terms, so get 2x, right? Then plus 10 equals 3. Now we can move this positive 10 to the other side to be negative. So 3 minus 10, that's negative 7. Then we divide by 2 on both sides. So x equals to negative 7, sorry. X equals to negative 7 over 2, a fraction. Right. Then once we have x value, we just go back. Right? Go back to the first one, or the second one is okay. Let's go back to the first one. So substitute x as negative 7 over 2, 5 times negative 7 over 2. Let me highlight this value. So we solved for x. So solve for x. We substitute into the first equation, 5 times negative 7 over 2 plus 10. So 5 times negative 7, that's negative 35. So negative 35 over 2. Then we need a common denominator to combine with 10. So we change 10 to be 20 divided by 2. Now we have a common denominator of 2. So we can combine the numerator. So negative 35 plus 20, that's negative 15. So negative 15 over 2. So our solution is a point. So the two lines, the system of equation has a solution. X value is negative 7 over 2. Y value negative 15 over 2. If we graph it, the two lines will meet at this point. Anyone has any questions? Okay, this is a substitution method. Same thing for this one, right? So y equals negative 4x minus 7. We can substitute the y value as negative 4x minus 7. And plus 2x equals negative 11. Then we solve from there. Negative 4x plus 2x, that's negative 2x, minus 7 equals negative 11. We'll move negative 7 to the other side, or we add negative 7 on both sides. Negative 11, add 7, negative 4. We divide it by negative 2 on both sides, x equals 2. Then we substitute 2 into the first equation, or we could do the second equation, no problem, right? So let me highlight this value. So we substitute 2 for x. So negative 4 times 2, that's negative 8, minus 7, that's negative 15. So those two lines meet at 2, comma, negative 15, which means the system of equation has one solution. X value is 2, y value, negative 15. Anyone has any questions? Okay, that's called substitution method. So substitution method, we want to solve one variable. And for those two examples, y is solved. Y is solved. Solved means it's all by itself, and it's 1y. And sometimes we can solve for x, 1x. Then we substitute its value. So the second method is called elimination. Okay, we would add the two equations or subtract the two equations. Let's review additive property. Okay, so if we have a equals b and c equals d, that's a plus c equals b plus d. Right? We add the left hand side, then we add the right hand side, and the equal sign stays to be true. If we have a plus its additive inverse, negative a is always 0. 2 plus negative 2 is 0, 3 plus negative 3 is 0, 1 plus negative 1 is 0, so on and so forth. Okay, we call additive inverse. So a and negative a are called additive inverse because we have another inverse, multiplicative inverse, like a times 1 over a is always equals to 1. Right? That's called a multiplicative inverse. So here's addition, additive inverse. So we use a standard form of line ax plus by equals c. It doesn't have to be this way, but you could make it this way, all right? So ax plus by equals c form, like 3x minus 2y equals a, half x minus 4y equals 0. The key is we want to line up the equation with the equation, the variable with the variable, with the same variable. So the x term with x term, the y term with the y term, the equation with the equation. Okay, that's important. If these two y's on the other side, that's perfectly fine. Then the negative 4y has to be on the other side too. Basically, we want to line up the variables, the same variables vertically, and the constant. Okay, we want to line up. Let's see this example. This is already lined up, right? 2x minus y equals 10, and x plus 2y equals 4, already lined up. But if we add or subtract two equations, we won't be able to get rid of any variables. Right? Elimination means we want to get rid of one variable. Right? The word elimination means we want to get rid of one variable. Let me type in here. Elimination, to get rid of one variable. It could be x, could be y. That's the purpose. So if we add or subtract directly, we won't be able to get rid of any. So what do we do? Oh, you see, if we try to add, hold on a second, let's try to get rid of variable y. Think oh, okay. We want to get rid of y term. All right. Here we want to get a variable y. The first equation will have -1, negative y. The second equation will have positive 2y. So we need to make the first equation to have a negative 2y. Because negative 2y plus 2y equals 0, additive inverse. So which means we need to multiply 2 for the first equation. If we multiply 2 with every term, we have 3 terms, right? 2 terms on the left, 1 term on the right. So every term has to be multiplied by 2. Then the equation stays to be true. So 2x times 2, 4x. Negative y times 2, negative 2y. 10 times 2, 20. So the first equation now becomes this. Well, we rewrite the second equation underneath. Now we can add vertically, right? 4x plus x, that's 5x. Negative 2y plus 2y becomes 0. That's the key. That's why it's called elimination. We want to get rid of one variable. Then 20 plus 4, this is 24. So we get 5x equals 24. Then we divide by 5 on both sides, x equals 24 over 5. Then we substitute into any of these equations. Well, let's substitute into the first equation. So we have 2 times 24 over 5 minus y equals 10. 2 times 24 over 5 becomes 48 over 5. Then we move 48 over 5 to the other side. It becomes a negative. And we want to change 10 because with fractions, we want to change 10 to be a fraction. So 10 becomes 50 divided by 5. 50 divided by 5 indeed is 10, right? But now we have a common denominator of 5. So we can perform this subtraction in terms of the numerators. So 50 minus 48, that's 2. Right? So that's negative y. Negative y equals to 2 over 5. So y equals to negative 2 over 5. So the solution is 24 over 5 for x value, negative 2 over 5 for y value. Any questions? Ajita, yes.
Professor, can you hear me?
Yeah, I can hear you. Yeah.
Okay, so just to clarify, the
Yeah.
first thing to do is to isolate one of the variables.
That's for that you are talking about a substitution method to isolate one variable.
Understood. Thank you.
Okay. Elimination, we don't have to isolate. Elimination, we want to line up. Okay, elimination, you see here, we want to line up x term with x term, y term with y term, equal sign with equal sign, constant term with constant term for elimination. Yeah, basically we want to line up x term and y term and add them vertically. All right. So let's see this example. This is another example. So if y equals negative 5x plus 3, and this is y equals to 2x minus 1. This is great, right? But if we want, we can multiply negative 1 for the second one. If we want to use adding, if we want to add, we can subtract, right? If you know how to subtract, you do y subtract y becomes 0. The negative 5x subtract 2x and negative 7x. 3 minus negative 1 becomes 3 plus 1, which is 4. You can do that. You can use subtraction. If you don't want to use subtraction, you want addition, you need to change this y to be negative y, which means you need to multiply negative 1 for 3 terms. Then it becomes a negative y equals a negative 2x plus 1. Now you can add, right? Y plus negative y equals to 0. Negative 5x plus negative 2x and negative 7x. 3 plus 1, that's 4. So get this. Because 0 equals to negative 7x plus 4. Then we move 7x to the other side, become positive. 7x equals 4. So x equals 4 over 7. Then we substitute into the second equation, right? 2 times 4 over 7 of new x value. Then minus 1. Right? That's the second equation. And 2 times 4, that's 8. 8 over 7. Right? 8 over 7. Well, 1 is a 7 over 7. Right? So then 8 minus 7 is 1. So the solution is 1 over 7 for y. Right? So x value is 4 over 7. Y value is 1 over 7. So this is the solution for the system above. Or we can use substitution method, right? Because y is solved, we can use substitution method. So we can substitute this y with this negative 5x plus 3. Then we'll have negative 5x plus 3 equals to 2x minus 1. So we'll move negative 5x to the right-hand side, become positive, right? 2x plus 5x, that was 7x. Then negative 1, we move to the other side, become positive. 3 plus 1 is 4. So we'll also have 7x equals to 4. And divided by 7, we get x equals to 4 over 7. Okay, so elimination or substitution, either one you can use, but just master one. Okay, to know both, but master one. Any questions? I think I'm missing something. Hold on a second. Did I delete something? This is only one equation. 2x plus y equals 4. Oh, okay. Let's see here. So I have those two equations. Okay, this we see the second one can be simplified, right? Because we can divide by 2 for the second one. If we divide by 2, we get negative 2x minus y equals 0. Then we can add those two equations. Because this one, let me just copy this one. So the first one, divided by 2. So this one divided by 2. Right? This one divided by 2. Divide the second, divide the second equation by 2. So then the first equation we can, I'm going to write underneath so to compare. Right? Even better, we divide by negative 2. Let's just divide by negative 2. Okay, if we divide by negative 2, we get positive 2x and positive y. You see now, compare with the first equation. The left-hand side is exactly the same. The left-hand side is 2x plus y, 2x plus y. But the first one equals 0, second one equals 4. So the two equation means 0 equals 4. If we have this negative 1, negative 2x, negative y, we can add those two equations, right? Once we add those two equations, we get 0 equals 4. Because negative 2x plus 2x equals 0. And negative y plus y equals 0. Right? So that means 0 equals 4. What does this mean? 0 will never be 4. So false statement. False statement is saying those two lines are parallel. No solution. They will never intersect. Okay? If you try to find a slope, they have the same slope. Let's see this example. The first equation is 3x minus y equals 1. Second equation is 6x minus 2y equals 2. We see the second equation can be simplified. right? We divide by 2. Divided by 2. Get 3x minus y equals 1. This is exactly same as the first equation. Exactly same as the first equation. If we keep solving, we will get 0 equals 0 or 1 equals 1. We will get a true statement because those two lines are exactly the same line. So when we draw a graph, we draw the first one, and the second one is on top of it. Let's see this one. We have 5x minus 2y equals 4. The second equation is negative 15x minus 7y equals 14. This one looks complicated, right? Maybe you want to get rid of x term. We multiply 3 for the first equation. Okay, so we multiply 3 for the first equation for everybody. This means multiply 3 with 5x, multiply 3 with negative 2y, multiply 3 with 4. So 3 times 5x would be 15x. 3 times negative 2y would be negative 6y. 3 times 4 would be 12. Now, take down the second equation. 15x add negative 15x will be 0. That's how we get rid of x term. So add those two equations. Negative 6y plus negative 7y will be negative 13y. 12 plus 14 will be 26. Right? Then divided by negative 13. So y equals to negative 2. Once we get the y value, we can substitute this y value into the first equation or into the second equation to get the x value. So substitute into the first equation. 5x minus 2 times negative 2 equals 4. Negative 2 times negative 2 is positive 4. So 5x plus 4 equals 4. Subtract 4 on both sides. 5x equals 0. Divided by 5, x equals to 0. Right? So the y value is negative 2, x value is 0. So 0 comma negative 2 is the solution of this system. Anyone has any questions? Let's see some applications. A small ice cream company estimates its revenue. Revenue means how much money they can make. By the equation R of x equals 4x. Okay. Revenue, so this is revenue. And x, what does x represent? X represents the number of ice creams are sold. Okay. So the revenue is each ice cream is $4. Okay, that's why it's 4x. Each ice cream is $4. And it has cost function. Cost function we call C of x, which is 2.5x plus 950. Well, 950, right? 950 here's constant represents the overhead of this business. 2.5x means for every ice cream they bought with $2.50. But they want to sell revenue, see, they want to sell each ice cream by $4. Right? So 950 is the overhead to do business. Question: how much is the cost of each ice cream? How much is the cost of each ice cream? How much is the cost of each ice cream? Okay, to buy, right? For people to buy. The revenue is 4x, which means ice cream is sold. Hold on a second, but this is cost. Cost, we should do this. how much is the cost of each ice cream? How much? Okay, let me do this. Let me change this. How much? What is the price? What's the price of each ice cream? Well, of each ice cream, the R of x equals 4x gives the price of each ice cream is $4. All right, because this is revenue function. How much money they could make? You know, they sell each ice cream for $4. So totally depends on how many they sold. So that's 4x. Which is R of 1. So when x equals 1, that's just one ice cream. So if it's one ice cream, you know, what's the price? 1 times 4, which is $4. So this basically interpret this function. B, how many ice cream must the company sell to break even? Break even means the cost equals to the revenue. Cost equals the revenue. So what do? We just equal those two functions. You know, R of x is 4x, C of x is 2.5x plus 950. Then we subtract 2.5x, or we move 2.5x to the left-hand side. We have 4 minus 2.5. If sometimes we don't like to deal with decimals, right, we can multiply by 10 for this. We multiply everyone by 10. So 4 times 10 is 40x. 2.5 times 10, 20x. 950 times 10, 9,500. Then we can do subtract 25x on both sides. So get 15x equals 9,500. We divide by 15. So in the end, we get 1,900 divided by 3. Estimate x is 634. So they have to sell 634 ice cream. You know, the revenue, they can cover the cost. They can break even. Which means they don't make any money, but they don't lose any money either. So that's cost. That's called a break even. The cost equals to the revenue. Anyone has any question? Okay, let's go to the next example. Oh, C. C is what's the margin of profit? Can I bring this up? Probably no. No, okay. What's the margin of profit? Well, profit is the revenue subtract cost. If 700 ice cream are sold, well, first we need to find F of 7, R of 700, which is 4 times 700, which is 2,800. The cost of 700 is 2.5 times 700 plus the overhead 950. Yeah, we calculate, we get 2,700. Well, the profit just 2,800 minus 2,700, which is $100. D part, what is the margin of profit if 400 ice cream sold? We do the same thing, right? So revenue for 400 is 1,600. The cost of 400 is 1,950. Okay. So we do subtraction, then we get a negative number. So that means the ice cream shop lost $350 if they only sell 400 ice cream because of the overhead. Business, you always have overhead. Any questions? Let's see the next example. Heather has been offered 2 options for her salary as a trainer at the gym. Option A would pay her $25,000 plus $15 for each training session. Option B will pay her $10,000, but $40 for each training session. So how many training sessions? And we use a variable S. Would make the salary options equal, which means option B and option A will cost the same amount of money. And we use S represent the number of training sessions. So option A, let's name a function A of S, right? The one-time pay is $25,000, the salary. The commission part is each session $15. So if S is 1, there's $15. If 2 sessions, $30, so on and so forth. So that's why it's 15S. A linear function, right? Option B, she only get $10,000 as a base salary, but then commission-wise, for each session, she gets $40. So when those two options, cost the same amount, we just equal those two functions. Then we solve from there, solve S from there. So 40 minus 15, we get 25 S. 25,000, subtract 10,000, that's 15,000. Then we divide by 25 on both sides. So 1,500 divided by 25, that's 600. Okay, so if the training sessions are 600, okay, the two options are equal, are the same. Anyone has any questions? So here you see we need to form function, right? We need to form a function. They interpret the English words into mathematical equations. Anyone has any questions? Okay, let's go to the next one. Mario wants to put a fence around a rectangular, right? What's a rectangular? Usually the 7 by 11 inches paper is a rectangular. Pool in his backyard. Since one side is adjacent to the house, he will only need to fence 3 other sides. There are 2 long sides, and the 1 short side is parallel to the house. So he needs 155 feet of fencing. So that means the perimeter, the 2 long sides, plus the 1 short side, totally equals to 155. To enclose the pool, the length of the long side L is 10 feet less than twice. 10 feet less than twice the width. Call the width W, right? So this means L equals to twice the width is 2W, 10 feet less minus 10, okay? So you can think L as a function of width. Length as a function, length depends on the width. So L equals to 2W minus 10. Now we have this 155. So 2 long sides means 2L plus 1W equals 155. Right? So 2L plus 1W equals 155. Then we know L, okay, can be substituted using W. That's 2W minus 10. So get 2W minus 10. For 2 times 2W, 4W, 2 times negative 10, negative 20, then plus W. Right, so we form the equation. 2 long sides plus 1 short side totally equals 155. Now we move negative 20 to the other side, become positive. 155 plus 20, 175. 4W plus W, that's 5W. So W equals 175 divided by 5, which is 35. With width, we can find length, because the length is 2 times the width minus 10. So 2 times 35, 70, minus 10, 60. So the width of the swimming pool is 35. The length of the swimming pool is 60 feet. Anyone has any questions? Let's see this example. I think this is the last example. Geraldine has been offered positions by 2 insurance companies. The first company pays a salary of $12,000 plus commission of $100 for each policy sold. The second pays a salary of $20,000, right? Higher base salary, but lower commission, okay? Lower commission rate. The first one is 100. So the question is, how many policies? Well, we'll call the policies P. We use variable P to represent the number of policies will need to be sold, so the total pay is the same for each job option. Okay, so we call the policies being sold by P. So for the first company, let's call F of P, okay, which equals 100P, because for each policy being sold, he gets $100. Then plus business overhead. Plus the salary. This is talking about salary. Plus base salary, she gets $12,000. Right. Second company pays her $20,000 as base salary. However, for each policy sold, she only gets $50. So now you see we get a system of 2 equations. Okay. Then, but we don't really need that. What we need now, because this is asking, you know, how many policies being sold for those two, for the total pay is the same. That means F equals to S, right? So F equals to S. Then now we solve. So 100P minus 50P, because we're going to subtract 50P on both sides. So we get 50P. 20 minus 12,000, we get 8,000. Then P equals 8,000 divided by 50, which if we don't want to use calculator, we can simplify 0, 0, which is same as 800 divided by 5. Well, which also equals 8 times 100 divided by 5. Well, we know 100 divided by 5 equals 20. So 8 times 20, 160 policies being sold. So if there are only 160 policies sold, then the 2 companies pay her the same salary. Any questions? Anyone has any questions? Let's see. All right, I have 30 of you here. If no questions, I'm going to talk about the first exam. Okay, pre-exam quiz is due today, or maybe it's due. Yes, okay. Pre-quiz. Let's see, pre-quiz. Pre-exam quiz. Where is it? Okay, this exam 1 practice and pre-exam quiz. Where is pre-exam quiz? Exam 1 practice problem.
Yeah, so this was the question that I had before.
Okay, right. What I
About
don't.
the quiz.
What is the pre-exam quiz in chapter 4?
No, I just like got it. Like if you scroll up, like if you go to the top, like it's there. Like for me, I don't know like about how the teachers one works, but like if you go all the way up, by like the
Okay.
assignments that's due today, that's where it is for me.
Oh, you click on it?
No, so I do like where it says Thursday, I do show all. Like if you go down, like no, like if you go like yeah, where it says show all, that's where it is for me. Like
oh,
yeah,
is
right
this
there,
one?
yeah, pre-exam.
Oh, okay, okay. Oh, okay, due tonight. All right. Let's open this. Okay, I don't have to open this. So your question is you did. Let me go to gradebook.
Yeah, I did it, but the questions that were like not based on math.
Okay. Let me find you, Mariel.
Yeah.
This is you, right?
Yeah.
Okay, so let's see, pre-quiz, pre-exam quiz. How do I see pre-exam quiz? So this is a quiz. Let me see this pre-exam quiz.
Like if I like where it said to sign my name, like I got that question wrong. But like it wasn't like a question. So like I shouldn't have gotten it wrong.
Oh, I have to get to it to see it. Hey, why I don't see you anymore?
I'm right there, yeah.
Oh, here. Here, so you see pre-exam quiz sprint. That's this one, 5.5, right?
Yeah. I think.
So you should get 10. You were not able to get 10.
No, like I got all the questions right. Like all the questions were right. I got them all right. I did it twice because it gave me like the first question wrong, but like the first question isn't like it's not like a question that should be marked wrong because it's like write this or copy this.
For me, 5.5 is the highest grade. I think maybe it's just worth 5.5 points for this quiz.
Oh yeah, I don't know because it just like I did it twice and it kept saying that I got the first question wrong. So like I didn't want to get it wrong for no reason.
You see,
like
Jason
I got 100 on it. I got 100
on it. Okay, so probably 5.5 is the highest. So you did get a 5.5. I don't see any grades higher than 5.5.
Okay, yeah, because I assume that everyone also got the first one wrong.
I see. So I see 4. I see 4.5. I see 4.
I think everyone's just getting the first one wrong. Because, like, I guess they're looking for a specific, like, signature for an answer.
Oh. Let's see. Oh, do I have to click this? Oh, I have to click on that. Then okay. I click on that. That shows up. If I click on the.
Oh, and someone also just wrote in the chat, which is also true, that the same thing happened for them with the signature and also where it shows like where it says to show your work, like it doesn't give you like the full credit because yeah, like this I got this one wrong and where it says show credit, like I got the actual answer right, but like since the show credit like isn't marked yet, I got like a yellow check instead of a green one because it wasn't marked yet.
Hold on a second. Let me understand this. So are you talking about this guy?
Yes.
Question 1.
Yes, I got it wrong.
Question. How can you be wrong for the question 1? Question 1, see, you just write.
Yes,
I will not use any other. Right.
Yeah, so I copied it word for word. I did all the commas, I did the periods, I did the capitals, and then I even tried it by copy and pasting the actual thing to copy, and it just did not, like, it marked it wrong both times, I assume because of the signature.
Huh. Okay. Jason, what do you want to say?
He was also saying that where it says the second question where it says like an actual math question, and then it says to show your work. So I didn't get that one fully correct because it wasn't, like, half of it wasn't marked.
Okay. Let me explain that point. Okay, for this one, hopefully the day when you really do exam shouldn't have any problem. For the question one, just some academic stuff. Then for this, you have to show your work. Okay, either you type in here or you can attach. You can take a picture,
So
attach it here.
I attached my work.
Then
Let me finish.
So the system only give you grades for this part. The system will not give you the full credits, and the partial credits will come here, and will need me to go into your exam to give you the partial credits. So I need to check your work for the true exam.
No, I
Let me
know.
check your work, give you credits.
I know. I guess we're just saying because that's why the highest grade is a 5.5, because, like, it's partial credit and then also the first one's.
That's right. Let me see. Let me just go back. So if I go to, let me just check it. Oh no, I have to go to grades. I have to go to grade book. Let's see quiz. Probably I have to do, what do I have to do? I have to collapse. No, if I collapse, I get this. Expand, pre-exam. Yeah, pre-exam quiz. Let's check yours. 5 point. That's Jason's. That's yours. So let me go to yours. Yeah.
Also, like, the first time I just stopped. Like, I didn't even finish it because I got the first one. So I just wanted to submit
Don't worry
it.
about it. For the first one, don't worry about it.
Yeah.
Okay. For the second one, you see, you did it right. So but you didn't get full credits. So this full credits needs me to go in to give it to you. Now I understand why it's only 5.5.
Yeah, it's just like also the first question, you see that it gave me wrong.
Yeah, don't worry about the first question.
Okay, thank you.
Yeah, don't worry about the first one. Okay, any others have any questions? Okay, let's see how's the homework going for everybody. Homework, so this is the homework part. Okay, looks pretty good. Homework. Christina only about 12%. David, is David here? Only 0.7%. This is a Kelly, only have 11%. Then Giovanna, only 11%. That's me. This one is not here. This one is the other classes. So the rest of you are doing fine, doing great. Oh, Chantel, only 7.6%. You guys have to work a little bit harder on homework. Homework is super important because your quiz, your exam, all based on your homework. If you can do your homework, you can do quiz, you can do exam. All right. Camille, 15.5%. So you guys make sure you do your homework. Randomly, I think the rest of you are fine. Randomly 31.54. Great. You're on top of it. So how? Okay, let me just go slow. See it. right? Any fat 32.2.
Question.
Yeah.
On the pre-exam quiz, I got the question where it's like how many hours can I take my quiz? Does that affect the grade itself?
What is that? What is that? Let me understand. Let's go to the quiz.
Yeah, after the signature thing, it said X, and then I got the actual question right. I uploaded my work, but then the 2 questions on the bottom where it was like no, after question 2.
After question 2.
Yeah. Those, yes, question 3. I got question 4 wrong. Does that ruin my grade?
You got a question 4 wrong. Yeah.
Yeah.
You will, right. You won't get full credits, but you will get partial credits for something you did right. For question 4, right? You only talk about question 4.
I got the bottom part wrong. I got the if you begin the exam on Monday, blah blah blah. I got that wrong.
Okay, if you get you get the first 2 right.
Yeah, I
then
got
you'll get credits for the first 2. Yeah.
Yeah, but does the because on the instructions it said that only the actual question, like the plotting question, was the one that you're gonna look at. The other 2 were just like did they count too? Part of the quiz?
I do not. I'm so sorry. I don't understand this question. What do you mean other 2? Other which 2? Which
Question
other 2?
1. Question 1, is that the only question? I mean, sorry, question 2. My apologies. Question 2, is that the only question that you're looking at? Or are you like let's just say I got the question right, which I did. Does that mean I got 100? Or are you also going to take into consideration 3 and 4?
Oh, there's only 4 questions, right?
Yeah.
Yeah. So for this one, okay. For this one, actually, it's not material wise. For this one, pre-exam quiz is for you to get familiar with the format of the exam.
Yeah.
Don't worry too much about this. All right.
Okay.
Don't
So
worry
it's not
about
going
too
to
much.
affect my grade too much?
No, pre-quiz, right? Don't
All
worry.
right, thank you.
Don't worry too much. It's really important for you to know how to type, how to show your work. Basically, you need either you can type in here or you attach to it. That's the important part.
Yeah, I did that.
Okay. Yeah.
Okay, thank you.
You're welcome. Okay. Any other questions? Do you still want to see? Anyone didn't see your grades for homework? Let me just go slow so everyone can see it. Only those, I mentioned the names a little behind. The rest of you, I think, are doing fine. It's above 20. Above 30 would be the best by this point. Right. Above 20 or around 20 or below 20, work a little bit harder, please. Okay, if anyone has any questions. So, next Saturday and Sunday, I'm going to show you, I should show you this. Exam 1. You see exam 1 is here. Exam 1 opens. Let's see what time it opens. Exam 1 becomes available on March 4th. Once it opens, so once you start, so you have to pick two hours during the day, okay? You can pick Saturday or you can pick Sunday. The 2 hours you can concentrate because once you start your exam, there's no pause. You have to finish in 2 hours. Let's see questions. Is it possible to make up homework because I missed one by accident? As I told you, the professor, he doesn't want to give anyone late pass for this because if he changes, I'm not able to change anything. You see, I'm not able. I don't have a privilege to change anything. So the coordinator changes everything, but he has a policy. He's not going to change it for anyone. He's not going to change anything for anyone because he had so much headache already. Sorry. Do we have an? And also, don't worry about one homework or 2 homework because it doesn't take much of a grades. What's more important is your exams. All right. The 3 exams are super important for you. You needed to. If you miss the homework, don't worry about it. Let it be missed. You focus on your the material, focus on learning the material, focus on the exams, all right? Because the exams, it takes a big chunk of your grades. Do we have an opportunity for extra credit? I don't think so, not from him. Because, you know, this course has like over 10 sections, and the department chair happens to be the coordinator. So he's having a lot of headaches. Kiana, what if you get accommodations like receiving extra time exam? Oh, that would be different. If you have something, it's called for special needs. I think for special, if you have special needs, right, you need to get some documentation, and then you have to go to a certain department or certain, you know, you have to go to certain people, and those people will issue you some document. Then they send the document to me and to the department chair to tell us you need extra time. That's how it goes, all right? So if you have some special needs, I have to go to my other class. Yes, if you have no questions, you can leave. You're a free bird, so you still have time. So this time you can do your homework, all right? Yes, let me stop recording.